Hey guys, welcome to episode 3 of this series where we work on building a web application using Rust. In my previous episode, we basically worked on the database setup. Today, what we'll be looking at is the asynchronous APIs to basically build a kind of a framework. We will be able to leverage channels from Tokio that allows for a very high concurrency. We'll basically be running the entire database thing in its own thread, and utilizing message passing, we'll be able to communicate between separate threads. The server thread and the database threads, we'll be able to communicate between them. So now when it comes to Tokyo's channels, there'll be basically a couple of different kinds of channels that we'll be really leveraging today. The one main one is MPSC channels. These are it stands for basically multi-producer single consumer channel. The idea being that you could have multiple producers which are sending messages on the channel, but they should really be only one receiver who would be listening to these messages and be able to handle those messages and perform certain action. And this is, in a lot of ways, this is basically similar to buffered channels in Golang. Then the other kind of channel that we'll be utilizing also are one-shot channels, which as the name suggests, are meant for single use. So there will be one producer and then there will be one consumer. And so the MPSC will be utilizing that for the database communication channel from multiple places, from various different API. Will be able to send messages to our database thread saying, hey, I need this data. And within this communication, we will also be basically utilizing one-shot channels, which would be basically used by the database thread to send back the data. Some of the basic things that we will need for managing this would be obviously to define our message type, what exactly our message should be. Once we have that, then we basically can, for instance, we can create a channel this way. When we create a channel, basically we get both a sender and the receiver, and so typically you use the sender to actually send the messages, and receiver would be the one where you can use that to receive messages. And like it's shown, so we can utilize some Tokio spawn to actually create these threads which can do the parallel execution when we want to communicate between multiple threads. So imagine, so this would be the database thread, for instance, and maybe this is a server thread. So in order for us to facilitate the communication between them, basically we leverage these channels. So if you scroll down a little further, you'll see now here is where we talk about how to actually receive the responses. Basically we utilize, like I said, was one-shot channels for that. So for instance, when we define our message types, we will embed the one-shot channel senders within these messages, so that when the manager is actually listening for the messages, when it receives a specific message which would include all the data required for us to resolve that action, it would then finally be able to send back that data to the original caller through this responder or a sender. And that's essentially what we'll try to do. Now, so let's start with a little bit of refactoring. I think we already have this much of our database. However, like I said, we'll be creating a manager. Rather than pollute everything within this, what I would like to do really is create a separate DB sort of like namespace or a folder, and where we can then have multiple files for these different things, and we'll make sure we export them. And so how we do that is, first we will create a DB directory, then we will move this, for the time being would be to the DB directory. We would have to obviously create a special mod.rs file. This is a file which will act like an entry point for the module DB, and this is where we essentially will be describing or exporting whatever things that are needed, and then make them publicly available through this. So here, at least for the time being, what we will do is, so first we will have to load the mod DB, right? It's here, we'll load the mod DB, and then we will export what we want to export. So we will export the DB and the URL map for the time being. This will allow us to the main and still be able to do exactly whatever we're doing, right? We'll still be able to do all this, except that it's coming from the DB And now let's start working on the manager. I want to start working on the manager. So manager.rs. Obviously I want to create a struct for this. We need that for everything. What I'll do is I'll keep a reference to our db struct, and then I'll keep a reference to the actual receiver, and this will be a receiver of message for us. Okay, now what is the message? Let's define what a message should be. Message basically will be our type. So this will define exactly what we need. For the time being, we'll start with the URL maps, and which is basically, this would represent getting all the URL maps, right? The original query that we did, select star from URL maps. We'll try to embody that. So all we really need, we don't need any data here. All we need is to make sure we have the responder. And again, now we will create the so I think this should work. But basically, yeah, so we obviously, this would be a sender. However, in fact it will be of a vector. Okay, so what we will do here is we'll create a sender, and the sender would be embody the result type of some type T. In our case, it will be either URL map or a vector of URL map, and also a SQLX error, because there may be an error associated with the query that we're trying to make. If the data that we send is incorrect, for that reason we use that. Let's import the Tokyo stuff. Let's first do this. So now this will no longer be required. No, it isn't. Let's go to this thing, right? And what will I export? I will export message and manager. Okay. We'll ignore some of the other errors. What about this? It says unresolved import. Oh yeah, it's sync. It's inside sync. So this is correct. I think we don't really need anything, but just for being able to print out and look at these, we'll utilize debug. Okay, it doesn't know what db is, so let's import that. So now we have db. Let's do this, I guess. So this would be from MPSC. This would be the MPSC receiver. Okay. Right, and we will receive a message. Let's start with some of the implementation. So I'm going to implement manager, and we will implement the constructor, and let's just simply pass the db instance and the receiver. This we will be passing it from the main, right, and we can just return this. Now comes the important bit. Now let's start working on function we'll call listen. Now we don't need to return anything, but here is where we will do the manager part, right? The manager part being this specifically this loop, infinite loop. So what we will need is while let sum of message will be received on the receiver, right here we will, and then we have to match on the message, and we'll provide all the, right now we only have one use case, which is the get URL maps, and so we'll see what we need to do here for this specific. In fact, this is appropriate. This message get URL maps. We haven't imported URL map. My bad. Now this should be good. Now what we'll do is I also need another type alias. I'll call it say connection, and what this will be is pool connection of Postgres. And obviously we're getting this from SQLX. Now it's inside pool. And so why do we need this, if you ask? So now we'll implement the actual function get URL maps, which we will utilize inside the main listener. And like I said, we don't really need anything except the connection. So this will be the connection, and this should return the result vector of URL map and SQLX error. That's how we'll be doing this. Would be straightforward. Let's just write our query here. So we will utilize query as. We'll explicitly map this to this. So here will be our query. That's it. And fetch all and out. Yes, this should be good. And so we basically get our data and we just return it, and fetch all automatically wraps it in the result. And obviously the potential is that there may be SQLX error, so we'll see what to do with that. But okay, so we have a resp here, and what we now want to do is we will say, okay, these are the URL maps. This will be self get URL maps, and all we do is pass in. Now we need to pass the connection. Right, now what is the connection? Now connection would be connection we can get from db to acquire await. I think let's look at acquire. So we will also unwrap it. We should be getting a connection every time, I think. Makes sense. And so we think it should be stuff, right? Yeah. And we need to await. So this we will get the URL maps from, so we can actually directly just send this. And the thing is, because when we send it, there is a potential that there could be an error. So now if it's okay, then we don't have to do anything. However, if there is an error for some reason, let's log that in. Okay. Oh, okay. Yeah, I think this looks about it good. Now let's go to our main. Let's try making use of this. Okay, so we'll get rid of this for now. We won't be obviously running the query directly there. What we will do is, so we will first get our DB, then we will create our MPSC channel. So let's get the tptx dbrx receiver, atomic mirror receiver, and this will be from Tokyo sync MPSC channel. Let's use size of 32 And now we will utilize the spawn API to here. What we will do is we will create the manager instance. So we need DB manager and DB comma. We pass in this, we get the manager, and then we just say manager.listen await. It needs to be mutable. We don't use this. Now we have. So now once we've done this, this basically has spawned our DB manager thread. Now what we want to do is we'll use the dbtx, and now we will send here our message, and message is going to be, we will be sending the get URL maps message. And what does this need? Oh, this needs the responder. So now let's create that. So we will have a txrx, and this will be Tokyo sim one shot channel, and here we will send the sender. What I think is this guy can fail as well, so let's do this, and we need to await here. Actually, we don't need to do anything. If it succeeds, great. If it doesn't, we will print out our error. Okay, now what we need to do is our URL maps will actually be coming from Rx, and so we just literally have to await, because it's one shot channel, we don't have to receive. That's the only thing we can do. So now we'll get URL maps. Our URL map type is going to be a result of result. So isolate, we could do them directly in unwrap actually. So now our URL maps is going to be result of either the data. So if we do get, which is this is the actual data, so we just print it out. I believe here this error happens if we have failed to send to database manager. Yeah, for whatever reason we were unable to send to it, so either it stopped working or you know, here is where to get maps. Awesome. I think this should be good. Let's run this and see how this behaves. Awesome, we got our data. Okay, when you look at the manager, you'll see the beauty. So this is this, and we go to our main parallelly. There's a little bit of work here, of course, there is a little bit of work here. We have to do a bunch of different things, but so this is something, basically portion would be something that we'd be doing from within our API routes. Obviously then we would have to serialize it to whatever JSON or something and then send back. Let's go ahead and create all the other ones. So let's also have this guy. So we will, this would be the API we use to get a single URL map details. Then we will have a create URL map message. Let this guy actually send an entire URL map object. We'll use that object and then we'll process it and send back the created one. Update URL map. And the last will be delete. And here we just need the key and responder. Yeah, I mean, obviously this guy is going to complain because now we have to. So we'll have a key and the response. Let's also implement the other ones. So this is the minor difference here. Because we parameterize the actual key value, we can use bind to supply that value. This is better than any interpolation that you might want to do, because basically any SQL injection attacks would be plotted here. It will make sure it sanitizes and whatnot. Let's look at what create might look like. Here we want an entire URL map object. We want to return similar thing. Again, we want to obviously run our query. And now here basically we utilize the insert into key URL values $1 and $2, and we utilize this returning star. This basically what it does is after the insertion it sends back all the values. This we can use. So now before we do anything else, now we need to bind on for the $1 and $2. So the $1 would be the key, which is URL map.key, and then the other would be URL map.url and fetch one. Alright, that's it. Now we will key is private. Let's make it public. Now we need it to be public. So this is done. Update URL map. Update map set so $1 key is $2. First we will bind the URL, then the key, then fetch one. Last but not the least is going to be delete. Need the key. Delete maps. Key equals to 1. Yeah. Bind the key and fetch 1. Okay. All we have to do is just utilize this. So our URL map is going to be URL map and connection and the key. Alright. And then we have to do this all over again. Since this is going to be a recurrent pattern, what I'm going to do is we'll create a macro for this. We'll also capture two things. One of course is the and FTP. So we'll match on $m. Now we have two things. Either it's okay in case we do nothing, or there's an error in case we basically print out the error. Maybe this would be okay. We need two things. Okay. So now what we will do is we'll simply, instead of all this ugly bit, just build create. Let's look at what this will look like. First thing, obviously we pass the connection, then we pass on this URL. Wait, that's it. Delete. Cool, I think. Oh. That's because we can go to the main. So now we looked at getting all URL maps. Now let's look at maybe getting an individual one. And here we will give, let's use GitHub because we know GitHub exists in the database. What was the result, right? So we do have GitHub. Now let's look at being able to get its individual, a single one. Gotcha, we have to do this into here, but let's look at this anyway. We ignore them. Yeah, it's able to get that. Let's try creating them. Let's try creating a URL map, right? So before we, let's create a URL map. Let's use LinkedIn. So linkedin.com/in/7. Okay, then we have I guess we have to so we do create it. Yeah, I think this should work. We'll try to do that here. Yeah, so we've successfully added LinkedIn as well. So we were able to create it. Let's try maybe updating. So what I'm going to do is maybe I'll switch to the non-HTTPS route. I don't know why we do that, but just to see the difference. And so now instead of create, we will use update URL map, and everything else should be okay. It says it worked. Yep, it removed the HTTP, the S, the secure part. Awesome. Why not delete? Let's look at delete. Okay, and I want to remove LinkedIn. Bam, and LinkedIn has been deleted. So all our APIs do work. Alright guys, thank you so much. Please do support me, continue watching, please subscribe, comment, share, and do like the video. I'll see you in the next episode. Thank you so much.